We're given a Maclaurin series and asked to perform a number of operations on that series, namely finding the radius of convergence, using term-by-term differentiation to find a derivative, and then forming a product with another Maclaurin series. So each of the things we're going to need to be doing, I've referenced over on the right in blue. And let's start with part A. We have to use the ratio test to find the radius of convergence. Well, the ratio test simply says take two successive terms in the limit that n goes to infinity and require that resulting ratio to be less than 1. What constraint does that place on x? And the constraint that it places on the absolute value of x is the radius of convergence. So let's write the n plus first term over the nth term. So we'll write -3. The n plus first term takes us from n minus 1 up to n, x to the n plus 1 over n plus 1. Now instead of dividing, we're just going to multiply by the reciprocal, just to keep our fractions of reasonable size. And so we have n over -3 to the n minus 1, x to the n. Now this, we're actually taking the absolute value of this, and we're taking it in the limit that n tends to infinity. We're going to separate this out into a couple of different terms here. Let's write it this way. We've got the n over n plus 1 constraint. We can talk about the absolute value of that. We've got -3 to the n over -3 to the n minus 1. Absolute value of that. And then we have x to the n plus 1 over x to the n. So this first limit, as n tends to infinity of n over n plus 1, that's just going to be 1, because the discrepancy between n and n plus 1 as a fraction becomes insignificant as n tends to infinity. Strictly speaking, I should have the limit as n goes to infinity of this term also. But we can see that this is just going to give us 1 extra power of -3 in the numerator. And finally, this is just going to give us x. So what we're really doing is we're saying -3x, we're constraining that to be less than 1. And the corresponding constraint, this implies that x has to be less than 1/3. Therefore, the radius of convergence r equals 1/3. Part B just relies on the fact that we can do term-by-term differentiation and integration for an infinite series. And so we're simply going to write out the first 3 terms, taking the derivative of each term successively. First 4 terms. Are, what's the derivative of x? 1, what's the derivative of -3/2 x squared? That's going to be minus 3x. The derivative of this next term is going to be 9x squared. Now we have to go back to the general formula to find out how to take the derivative of the fourth term. But what are we going to have? We're going to have negative 3 to the third power. That's going to be negative 27. X to the fourth power over 4. And so when we bring down the 4, we're just going to be left with negative 27x cubed, because the 4 coming down will cancel the 4 in the denominator. So that's all there really is to be. And then they just want us to notice that this is a rational function. Well, for that we have to rely on the fact that a geometric series can be represented as 1 minus 1 over x. And so in this case, the x term that's here is clearly a negative 3x term here, and so we have, I'm just going to say this is a geometric series. Equivalent to the first term over 1 minus the common ratio, which in this case is negative 3x. So we can write that as 1 over 1 plus 3x. So it's a geometric series equivalent to this over the radius, over the interval of convergence. Finally, we simply have to take the product of two infinite series and find the terms up to degree x cubed. So we write e to the x from memory as 1 plus x squared over 2 plus x cubed over 6. And then we're just going to multiply those two things together. Just going to say multiplying by f of x. Well, we have one series which is 1 plus x squared over 2 plus x cubed over 6 plus an ongoing infinite set of terms, and that has to be multiplied by x minus three halves x squared plus 3x cubed. And it goes on, but the reason that we can stop at the x cubed term here is simply that because we're only asked to find the product of terms up to the third degree in x, we can just write out, well, what's the lowest degree term? It's going to be the 1 times the x. And so that's just going to be 1x. Now what's the x squared term going to be? Well, how do we get x squared terms? We get them from multiplying x by x. So that's a coefficient of 1. But we also, let's see, can't we get a minus 3 halves x squared times 1? And so we also have a minus 3 halves term. Now we'll find the cubic term. Where are we going to get those terms? Well, 3x cubed times the 1 will give us one of those terms. So put the 3 here. And how else are we going to get an x cubed term? Well, we're going to get it from the x times the negative 3f x squared. So that's that. And then we're also going to get it from this x times the x squared over 2 term. So that gives us plus a half. So writing that out, we've got x minus 1/2 x squared. And what is this? 3 minus 3 halves plus a half is 2.